The risks of going beyond 2 minutes are not worth it. And the damage that you're going to do to your tissues are not worth it.
What is it about cold in our body? Like, why does cold have an effect on us?
Well, that's an amazing question because when you look back at where we actually evolved and where we come from, you realize that humans actually evolved in the African savannah. So we spend most of our evolutionary time building these adaptations for heat, for humidity, for dealing with high temperatures. So we're not really good in the cold. We're very good in tropical conditions. We're very good at dealing with heat, especially if we're in the shade. But as soon as we get into the cold, our vulnerability is tremendous. We have very little defenses, physiological defenses, or even biological defenses to be able to survive. And we have to rely on our minds, and we got to rely on our capacity to build shelters, to make clothing, to work together to get our basic needs.
What is it about the cold that does it to us, though? It's like, what is happening kind of inside of our body that doesn't agree with the cold?
So as soon as we get in the cold, we start losing heat very quickly to the environment. And our body's going to say, we need to shut this down because if we keep losing heat to the environment at that rate, our body temperature will start dropping. Humans are endotherms. So basically, we're made to survive at a specific body temperature, and it has to be constant. So 98 Fahrenheit or 37 degrees Celsius, we're trying to maintain our body temperature at that temperature. In the cold, we lose a lot of heat. So we need to produce a lot of heat to compensate, to avoid having our body temperature drop. So the first thing our body's going to do is as soon as you get into cold conditions, is going to shut off anything going to the periphery. So to your hands and feet. And as you all know, when you work in cold places, your hands and feet become very cold and way before the rest of your body becomes cold. So this is very typical of the human response, and it just brings all the warm blood towards the core of the body and tries to keep the core at a constant temperature. But for humans, it takes a lot of energy to be able to do this, and we're burning a lot of energy to be able to maintain that body temperature.
When would you say that our body starts doing that? Is there a temperature where our body says, oh, it's cold now?
Any temperature below 33 is the beginning of cold exposure.
I just looked it up. 33 degrees Celsius is 90 degrees Fahrenheit. And I would consider 90 degrees Fahrenheit to be pretty hot. So we're essentially getting cold even in the middle of summer.
Yes.
Are we better than other animals at adapting and dealing with the cold? Or are we kind of, no, we're kind of one of the worst?
Definitely, we're very good at dealing with the heat. We got eccrine glands. We're able to sweat a lot from all over our body, which is a lot of animals are not able to do this. So we're very good at dealing with this. In terms of cold, we're awful. We're probably some of the worst mammals out there because our bodies are furless. And so that's a big disadvantage. The other disadvantage is a lot of people put a lot of emphasis on fat as being an insulator for cold. In our case, we're not like marine mammals. Marine mammals can actually isolate their blubber or their fat from the environment. So having barely any blood flow going to the outside, to the periphery, which means that they can regulate their temperature much better in the cold than we can. For us, our skin is a radiator no matter what, and we're always losing heat to the environment. We can have fat. The fat's going to modify your body shape and your body morphology, so the physics will be modified in the way you're losing heat to the environment, but we're still going to keep losing heat to the environment. So it doesn't provide that much of an advantage. So to put it on a scale, in mammals, we're pretty awful.
We start to get cold, and I would use the words technically, right, because it's at 90 degrees. At what temperatures will we kind of be like, okay, now you're really in trouble? Like, you're not just uncomfortable, now you're in trouble.
It's not a difficult question to answer, but it's a very interesting question because there's two ways of looking at it. I can tell you when you're troubled biologically, but there's also when you think that you're in trouble. And there's a bit of a distinction there. So I'll tell you biologically. Biologically, you're in trouble if you keep losing heat and you're not able to rewarm yourself. So there's two types of cold exposure. There's one type which is compensable, which I could be shivering like crazy and producing a lot of heat enough that my body temperature doesn't drop. So we call this compensable. It means that I'm losing heat to the environment, but I'm producing so much heat that my core temperature doesn't change. Compensable cold exposure. There's another type of cold exposure that often happens in cold water, which is uncompensable. And as soon as you get into cold water, you're losing heat so fast that you're not able to produce heat fast enough to compensate, which means that my body temperature just keeps dropping. So in cold water, you're always in trouble. Cold water meaning below 18 degrees Celsius. Again, this is something we can probably look up in terms of Fahrenheit, but 18 degrees Celsius and below, you start losing heat very quickly to the water. And if you don't get out within an hour and a half, you're going to become hypothermic. In cold air, you could always compensate. So there's always ways of compensating. But if ambient temperature becomes below freezing, then there's all kinds of risks that are added up. Some of these risks were going to be related to frostbite. Your hand blood flow is going to drop, your feet blood flow is going to drop, and then your extremities become very at risk of any type of injury. Any temperatures in between is also how you feel in that temperature. Some people go into cold and they panic, and they're actually very scared of cold. And I've seen, even in the lab, I've seen some people being terrified of being in cold temperatures and thinking it was burning them and they weren't feeling good. And that's all mindset. And the more you expose yourself to these cold temperatures, the more your mind becomes used to it, and you become more linked to the biology and less linked to the psychology of dealing with cold. The reason why humans are like this, that they're fearful of cold is a dangerous stimuli. And if you don't deal with cold and you don't make decisions, you could ultimately die or not be able to sustain your capacity to function and thrive, even feed yourself. So this is something where evolution made it in a way that we tend to be very concerned about cold, but you can also detrain this, where you can actually learn not to be, and that's what we do with the military. We actually train them to be able to face cold efficiently, to be able to operate in cold temperatures.
18 degrees Celsius is 65 degrees Fahrenheit, just for a quick kind of refresher to the audience. That seems like, man. So, okay, this is a complete aside, but I've always wondered this. Whenever you get in cold water, like, why do we take that, like you start breathing like that? Why is that?
There's a program in the UK, it's called, that they've been trying to, an intervention that they're trying to get everybody to understand is if you fall in cold water, you need to float first. Extremely important. The reason, if you don't float first, as soon as you hit that water, you will take a deep breath. And that's called cold shock. And it's a cold shock response. It's a reflex. And if your head is underwater, you will drown. So the first thing, more people have died of drowning in cold water because of cold shock than they've actually died of hypothermia. So you need to float first. So essentially, there are receptors right below the skin. And as soon as you hit that cold water, it will induce that deep breath. And again, you're going to just take a full inhalation. It's about 1 liter of air coming in. Again, you get 1 liter of water in your lungs, you're done. So this is something, it's just a reflex. And this is what, again, we train. Coming back to the military, this is something we train, because they do train to go into cold water. And we train to actually not take that deep inhalation and actually to learn to exhale as soon as you hit the cold water, because it's a way of regaining control.
I don't know if I'm going to really be able to like kind of quantify this question very well, but I think it will make sense in the sense that, like, okay, if we do this kind of training, you mentioned you work with the military. If we do this kind of training to prepare ourselves for cold, like, how much better can we get at handling it? Would you say we get you get a little bit better, or like, oh no, you can really change?
Yeah, you can really change. So you can get, even within 1 day, get amazingly better if you learn how to do it. And what we do is we actually trained the soldiers to use breath work to regain control. By understanding what's going on physiologically, understanding that reaction is normal, and knowing what to do with it, what you can learn then is how to almost embrace being in that cold water, or this cold temperatures. And when you hit that cold water, you barely get any reaction because you regain control immediately. So this is very quick to train. And this training for cold shock can actually last, even if you stop doing it, can last for over a year.
When you talk about kind of training, like, can you talk about what kind of techniques, things that people can do?
So none of this is novel. It's been used for thousands of years in many cultures. And people had used cold water or any type of very intense stressor to be able to learn to even meditate and be able to become in a zone that you keep control. And this is done mainly through breath work. It's done through even being self-aware of the dangers that you're facing and knowing that you can keep control even in these very harsh conditions. And so this is something where there could be many benefits in pushing your body outside of these limits and showing that your body is able to respond in a very positive way.
Is this in any way kind of like the old adage about exercise, right? Like my body starts telling me that I'm tired long before I'm actually really tired.
Yes, it's exactly the same thing.
When you look at the kind of training, is there any physiological changes that take place within people because of the training, or is it really just like you just get used to it? Like it's just a mental thing.
So muscles do change. When you expose muscle to cold, you're going to be shivering. And that shivering is kind of low grade exercise. And you will get some of the changes with cold exposure that you would get with low intensity exercise. And actually, because cold is such a potent stimulator, a lot of these changes actually occur much faster than what you could get during exercise and at much lower intensities. So cold has been known to actually improve even aerobic capacity and improve your muscles capacity to even deal with sugars, with glucose. So these are some of the changes that occur. Another change that can occur, and again, this is something brand new. Basically, when I say brand new, I mean 2009, which might not be brand new for everyone, but for me, it's kind of brand new. Before 2009, we never talked about brown fat, and brown fat in adult humans was not even a conversation. So we said that anytime somebody would get into the cold, all the heat being produced was basically from shivering, from the muscles being activated and shivering. So shivering is kind of it's not a synchronized movement of the muscles. It's just their muscles trying to produce heat. And that's the best way for humans to produce heat. But in 2009, there was 3 nominal papers that came out in New England Journal of Medicine that showed that adult humans have brown fat. So we knew that babies had brown fat, but we didn't know that adults actually retain that brown fat. So they found that brown adipose tissue in adult humans. And what we saw is when you cold acclimatize, some people increase their brown fat. So there's actually more, and the brown fat's role is just a furnace. All it does in the animal world is to produce heat. So it's not made to produce energy. It's made just to produce heat, to keep your bodies warm. So this is something that endotherms have. So these are tissues that do change in the cold. There could also be effects on the immune system and effects on inflammation, but this is not as clear as people seem to make it. So you look in the mainstream social media and people will say, get into the cold, it's going to improve your inflammation status, it's going to improve your immune system. This is actually not proven at all.
That's what I was going to ask you, right? Is about like kind of cold therapy seems to be all the rage. Is there any science behind that, or is it like this thing is just taken on a life of its own? And
extremely important question, because people seem to say that there's science behind it, and they kind of try to say, okay, this is what you do and it improves all these parameters. Right now, there's very little backing up any of these statements. So there is some research kind of showing that cold could have multiple benefits. And one of these benefits that is clear is cold is a stimulant. So as soon as even taking a cold shower or a cold bath will actually increase not only your dopamine, but actually increase stress hormones. And it gives you a bit of a rush. And this rush actually makes you feel good. And the dopamine makes you feel good, but the rush also coming from just doing that cold exposure, a cold shower would do it too. And of course, if the person feels better, that's a very important result, right? So the person's feeling better. So for me, if you think about therapy, cold does help. But now it's funny because especially in North America, it was funny being in Finland because the Finns tend to not go to these extremes. In North America, what we love to do is as soon as we find something, we make it into the biggest thing on earth, and it's the magic bullet for everything, and it's going to fix everything. So, and the issue that happened is people now started pushing the envelope. So they're using some of that cold and making some statements about the effects on the immune system and inflammation, but cold is not even standardized in the way people use it. So just like if I would say exercise is good for you, Well, you're going to ask me, what type of exercise? How intense should I do it? How long should I do it? How frequently should I do it? Well, we don't know for cold. And some people, if you say 2 minutes in ice water is good, they're going to think that 20 minutes is 10 times better, because the risks of going beyond 2 minutes are not worth it. And the damage that you're going to do to your tissues are not worth it. We still need to consider some of the risks. You can't just keep doing these cold water dips thinking that I'm not damaging tissues. And again, there's two types of injuries you can have. It's like frostbite, depending on what temperature that you're doing these ice dips at. There's also a risk of non-freezing cold injury. And the non-freezing cold injury was actually first documented in the First World War, and they were called trench foot. So trench foot is actually neurological damage. And if you repeatedly expose yourself to cold temperatures, you will damage your nerves in your hands and in your feet. And this can actually be permanent. And this is well documented in soldiers, by the way, in the UK and Canada, even in the US, extremely well documented that non-freezing cold injuries from repeated exposure to cold can actually be permanent damage to tissues.
I don't want to kind of put words in your mouth necessarily, but kind of sum it up for my understanding. It kind of seems like when we're talking about cold therapy that we know that we feel differently, right? And we know that people kind of feel energized or feel whatever, but it doesn't seem like there's any actual proof that from a biological perspective that anything is happening.
No, there's actually a paper that just came out in 2023. I just looked at it. I found it yesterday. And it's from University of Bern in Switzerland. And they showed that actually the Wim Hof method over 15 days had no cardiovascular advantages. And this showed actually very few benefits, even with the breath work and everything that was going on. Again, this is biologically, right? Does it mean that people are feeling better? I'm not discounting, and anecdotal evidence is still very good evidence. If people are feeling better, I mean, this is good. If they're not getting injured doing it, this is good. Biologically, a lot of these methods cannot be backed up right now. And this is part of the work that I'm doing in my lab at University of Ottawa. We're looking at dosing cold in a way that's going to be beneficial without going to the risks. And this is something that I want to bring to the military so we can actually make it into a real training program with cold and not be doing it the way it's being done right now, which is tremendously dangerous. And one thing that I want to mention is cold, especially ice water, would be like being struck by lightning. This is how dangerous it is to your body. And you get a vagal response. Your vagal nerve is going to respond to this, and you can actually end up in cardiac arrest. The other thing that can happen is also your blood flows being all diverted to the core, and your blood pressure just flies up. Again, large risk for cardiovascular issues. So it's not a safe practice. It's a practice that is actually tremendously dangerous if not well done. And people that stay longer than 2 minutes are putting themselves at risk big time.
Now, is that 2 minutes a day or like 2 minutes for what kind of time period are we looking at? Because somebody's going to be like...
So I do cold dipping maybe once every 2 weeks. Some people do it every single day. The risks of doing it every single day are tremendous. There are risks, and the risk is to damage your hands and feet. So I always tell people you need to protect hands and feet. You need to put gloves on, which is neoprene gloves. I use 5mm gloves. I use 5mm boots when I go into ice water. But again, what would be the benefits of doing this every single day? And none of this has been well documented. And I would say that the risks right now would be more of a concern to me than some of the metabolic benefits that I know of. And I've been studying cold for the last 23 years. So I know about cold exposure. And I don't see the real benefits right now of doing this. And the only thing I see is a lot of risks of how people are actually doing it.
So looking at it, like, why did we become obsessed with it then, right? Like, if it doesn't seem to really do much for us and can be dangerous, why do you think we became obsessed with it? And everybody's got ice baths and cold therapy and nitrates, whatever, and all that stuff.
That's a very good question. And when I started doing my PhD in 2000, I never thought cold was going to become what it is now. And it's amazing where it went. And we barely talked about it. In 2009, when brown fat was found in adult humans, everybody went ballistic. And the amount of papers that were published from 2009 and on about brown fat is humongous. People were just pumping out these papers saying that brown fat was the savior for anything related to obesity, diabetes. It was going to be the tissue that was going to solve any problems in the world. And of course, it didn't become that way. And it's a bit of a trend that happened. When you take something that might be good, this is very typical in mankind or humankind. I don't know why we do this, but we take something that might be good at a very low dose, and we always make it to an extreme. We always need to push it as far as we can and say, okay, now we got to do even longer, better, stronger. It's always kind of pushing the envelope, right? You know, you do a marathon, you do a triathlon, now you got to do the ultra triathlon. And it's always, cold became a little bit of this. And I think this is where we need balance. And I'll just give you an example. In the Ottawa region, there's a few groups that do ice water bathing. And I went to meet one of these groups, and some of the people there were so focused on staying in the water as long as they could. And for me, again, coming in as a cold researcher, I'm looking at them going, okay, this is interesting that people would even want to do this to that extreme. And I looked at their hands and feet, and they weren't protecting them, and the damage was tremendous, and I could see it. And I said, how are your hands? And you could see that even, you know, they had no circulation in the hands, and the feet were really damaged. But it was such a focus for them that this is the solution. This is what I need to do. Anything done biologically in excess, at some point will start hurting you. And I think cold is the same thing. So there's no risk, by the way, of cold air, unless it's below freezing where you could get frostbite. And with cold air, if you're well protected, you can go into the cold as much as you want. Cold showers is not a big deal either, because you're not exposing yourself to the heat loss ranges that you would find in ice water. Ice water is dangerous.
This kind of leads us into some of our listener submitted questions. So are you ready for some harder / listener submitted questions?
Shoot away.
Let's start with kind of, I guess, the easier ones on that scale, right? Like, so what is frostbite, essentially? Like, what's happening when somebody gets frostbite?
Kind of simple in a way. Like if you put meat in the freezer, you will get ice crystals being created in that meat. Well, if you put that even in living tissues, you can actually have ice crystals that are going to be forming within your cells. And the problem is with a living cell is you're going to rupture everything. So all the cell organelles, everything, the membranes will all be destroyed. So you basically end up with cell death. So a frostbite is different levels, depending on how deep it goes. So you could get a frost nip, which is just going to be kind of whiteness on your finger, or you can be on your nose. It's generally the periphery where there's less blood flow, your ears. Very typical. That's why with friends, when you go into the very cold temperatures, always look at the person. And if you see anything related to frostbite, you need to protect yourself. So the first level it would be a frost nip. You're just going to see a bit of white occurring. There's second level, there's third and fourth level, which are much, much deeper type of damage. But it's the same thing. It's just cell death from the ice crystal being formed, but deeper in the skin. So we have the epiderm on the surface and we have the derm right below it. And basically you start damaging the derm. And as soon as you start damaging the derm, you get, again, a lot of cell death occurring everywhere above. So, and some of that cell death is basically the tissue's gone, right? So amputations might occur and you're going to get, dark skin. So the skin's everything would be falling off. So you need to basically cut it off. So it's just ice crystals forming in tissues.
Are there certain populations of people that seem to handle cold better than others?
So this is a question that everybody seems to be very interested about. And I would say that physics dictates your risk for cold. So the way you exchange with the environment is going to be linked to your body shape and your body mass. Humans are generally not well adapted at all to cold. There's some populations, though, that would have morphological differences that would help them lose heat not as fast. Are they going to be less vulnerable to frostbite? No. Typically, what the Eskimos are Inuit, like we call them in Canada, the Sami in Finland and Scandinavia, would tend to be better adapted to cold temperatures. But a lot of what they do is behaviorally. So they're going to modify their behavior to be able to make sure that they don't get any type of injuries. So when I've worked with First Nations for many years in Northern Canada, and the decisions they make are always about protection. They will not expose themselves and risk any type of injury. So it's very hard to separate what is biological and what is linked to the behavior.
Most extreme example you can think of somebody surviving cold?
So the only way in the cold that you would be able to freezing will not do it. If you freeze, the tissues will die. So if it's extremely deep and you've been outside and your tissues are completely frozen, meaning that you're in ambient temperature that is well below freezing, you're not going to survive. You're going to die. You're going to lose parts at the minimum. But if you don't get out of that cold temperature and your body temperature keeps dropping, you will die. But there's that concept that you're never dead until you're warm and dead. So you still need to try to warm up the individual, because there's a chance, and it's been shown before, but it was mainly shown in cold water, where people almost they were dead, and when they rewarmed them from cold water, which again has nothing to do with creating ice crystals, you don't get that tissue damage to the same level. The only thing you're getting is the cooling of the body. And this has been shown even in infants, that if they fall in cold water, you do need to rewarm them. Because even after being rewarmed, and this is again in animals, it's well known in the animal world that some animals are able to go to very low temperatures. They almost seem dead. They're basically dormant, and then you rewarm them and they come back to life. Well, it seems that if you're able to cool fast enough in cold water, that you would be able to rewarm and come back to life. So there's that whole concept that there's that chance that you would be able to survive cold, but there's definitely no guarantees. And if it's below freezing and you got damaged tissues, you are losing these tissues. So again, your chances of surviving become less and less.
Does cryogenic freezing work? Are we going to be able to do that?
So it works for certain cells, and you need to kind of remove the water from the inside of the cell. And when you remove the water, then you can freeze it. Could you do it for a whole body? That would be extremely difficult to do. It's still the same principle, but would you be able to survive and be as you were before freezing? I kind of see it a little bit like meat you put in the freezer, right? When you put meat in your freezer and you leave it for 2 months, it's not a big deal. But if you leave it for 10 years, the meat's not going to be very good, right? It kind of still affects it to a certain extent. So I don't know much about that literature. I haven't seen too much about it, but in my mind, this would be extremely difficult. And I know some people have tried it, to be able to bring back a body to the same state as the body was before freezing.
You don't think it's going to work? It's not going to work.
I think it would be extremely complex. I think people will try it. I think people will try to see, are we able to do this? Because we are able to do it with, reproductive cells, and it seems to be working really well. So it is possible to do it with these specific cells. Could you do it with all cells of the body in the same way, including your brain, which is very sensitive to these fluctuations and especially changes in energy need and energy metabolism? You can destroy brain cells very easily. Even heart cells are very vulnerable. So would it be possible to do it with all tissues? I think it would be extremely challenging. So maybe we're going to be able to do it at some point, but right now I would have trouble seeing how we would be able to do it.
Are there any examples of people kind of like quote unquote freezing to death in warm temperatures?
Well, no, because it's physics, right? So because it's physics, you do need that gradient in temperature.
Claim about cold therapy that drives you nuts the most?
I think right now, what really bothers me is more about the immune system, because we kind of the immune system is a very complex system. And we try to simplify it by saying, okay, it's going to improve the immune system. And a lot of people have looked at, the changes in white blood cells, but there's far more going on than this. And even when you're sick, the white blood cell count changes. So people are making claims based on no evidence. And I think what bothers me the most is when people, especially with no training at all, no formal training in any field, I've taken a weekend course or a few courses, and they make these types of claims, again based on no science, or maybe based on a random paper from a predator journal that people are just trying to convince of the efficacy of cold exposure. I think this right now with the immune system is what bothers me the most, And also the fact that we don't talk about the risks, right? This is something that bothers me into anything that we do. We never mention that we can do this to the extreme and there's never any risks. It would be like saying I'm doing triathlons or ultra marathons and there are no risks. Of course there are risks, right? But we don't really want it. We always say, well, it's all about benefits. Well, cold, no, there are risks. The same with heat exposure, there are risks.
What are you studying now?
So right now, initially when I started my research, I was mainly focused on energy metabolism. I was trying to figure out what does the body need and use in the cold to be able to survive and operate more efficiently. So this was most of my PhD work was related to this. And I studied shivering quite a bit because I wanted to know how people shiver. And one thing that came up is with cold, because there's been so little natural selection around cold exposure that it was more behavioral. We get a lot of different ways of responding to cold. So we cannot generalize cold response in all humans on Earth. And even within a population that is very similar, there are a lot of differences in how people respond to cold. But recently, I studied brown fat. So in 2009, I was part of a team with University of Sherbrooke, Université Laval in Quebec City. And we built probably one of the top teams looking at brown fat changes in humans and how exposing yourself to cold regularly changed the brown fat and what was the exact role of that fat. And we're continuing this work. So this is something we're going to keep looking at for sure, because we want to know what is the exact function of brown fat. But doing all of this, I kind of realized, especially through COVID, I started reading more and started doing some yoga, starting doing some meditation stuff, breath work. And I realized that cold also requires a certain level of mindset. When I get into the cold, my mindset has to be right. And I need to understand my limits and I need to understand how far I can push. But there's also a whole aspect of using cold as a way of improving mindset and your mindfulness, your self-awareness. And a lot of the militaries around the world are actually looking at this and to be able to recreate the mind-body connection. And to be able to use cold in a healing way, where when I'm in the cold, there's nothing else I can think about. When I'm in the ice tub, what I need to focus on is to reconnect my responses. And so cold has been used quite a bit, even with pain management. So this is some of the work I'm kind of doing in parallel to my more fundamental cold research, because I do think there's a lot to learn and a lot to do when it comes to cold. And I think our bodies, if well done, can get a lot of benefits from cold exposure.
That is true, right? When I'm cold, the only thing I think about is being cold. I don't think about anything else but the fact that I'm cold. I mean, it makes you tough. I feel like cold makes you tough.
It makes you tough in a controlled way. It makes you tough in a situational awareness way.
That's pretty much all the questions that we have. Is there anything that you think that we missed or anything like that?
No, I think we covered quite a bit.
The only other thing that I would ask, right? Like when you look at populations that kind of live in the cold, that are in more extreme examples, right? Like I know you work with indigenous and native populations and worked in Finland. Do they have a fundamentally different approach to it than other places, than other people like somebody in the south of the United States would have? Like, do they look at it differently?
Yes, and I think this is something I learned from a Norwegian officer, an amazing man that I met in Arlington at a NATO conference. And he said something, and I don't know if everybody picked up on it in the audience, but for me, being French Canadian, I've been grown up on bases. My dad was in the military. My mom was also in the military. So I kind of grew up in north of Quebec City, and the temperatures were cold, much colder than what you get now because of climate change. But one thing that he said that really hit home with me, and I know a lot of people in northern United States and even Alaska will understand exactly what I mean. He said, to be able to do well in the cold, you need to embrace the cold. And so for me, I think this is the most important component of any culture that does well in the cold. Cold is not a big deal. Cold is just something that exists, that is there. And in Finland, this is what you see. People don't panic around cold, and they actually enjoy it. They embrace it.